So here's a few examples using that notation even more. So you've got 9p4. That would be 9 objects arranged in 4 positions. So 9 guys at the dance seated in 4 chairs. How many ways can you do that? Using factorial notation, 9p4 would be 9 factorial over 9 minus 4 factorial, which is 9 factorial over 5 factorial, which is like a way of dividing out those 5 chairs that aren't there. 3,000, how much? 3,024? Okay, so a few less ways for 9 guys trying to sit in 4 chairs. But still quite a bit. Still good?
Yep.
Okay. Here's just an algebraic problem. Can you prove to me, without punching it in on your calculator, that 100 factorial plus 99 factorial equals 101 times 99 factorial?
It won't even work on your calculator.
No, I don't know
It
how
should.
It just overflows for me.
Oh, so yeah, you can't do it on your calculator because it overflows.
How do you...
So you can prove it though. Here's how. Alright? I'm going to take 100 factorial and, well, before I do that, think about just 4 factorial for a moment. I could rewrite 4 factorial as not only 4 times 3 times, that's a long way, right? But I could rewrite it as just 4 times 3 factorial, because this chunk right here is 3 factorial. You follow what I did there? Okay? No?
Oh.
Right, I just took this chunk here and rewrote it as 3 factorial. Right? You could also go 4 times 3 times 2 factorial. Right? Because 2 factorial is just 2 times 1. See what I'm saying? Anyways, what you can do for this problem here is you can take 100 factorial and rewrite it as 100 times 99 factorial. Right? Same reason as over here. You follow what I did?
So how do you get 101?
Yeah.
I'll show you. But you follow what I did so far?
Yeah.
How I got this.
Yeah.
Okay. So I'm going to take this and place it in the spot of 100 factorial there. Okay. So that gives 100 times 99 factorial plus 99 factorial. Okay. Now I'm going to factor 99 factorial out of both of those terms. So I have 99 factorial times what? 100 for the first guy, plus just 1. Right? If I divide by 99 factorial in each of these cases. So I factor out 99 factorial, so I divide out 99 factorial here. That leaves me with just 100. And I divide out 99 factorial here. That leaves me, well, just with 1, right? Because they cancel. With me? And that equals just 101, right? So that's 99 factorial times 101, which is what we needed. Solve for n if np3 is equal to 60. This is a little tricky. Here's how you do problems like this. So I'm going to use permutation notation to solve this. So np3, that's just n factorial over n minus 3 factorial. Right, and that's equal to 60. And I need to know what n I could put in there that would give me a result of 60. So here's a little trick sometimes that you use when solving problems like this. Okay, don't miss this because this is an important tool. I'm going to take this top factorial and expand it until I get to n minus 3. Okay, so n factorial can be written as n times n minus 1 times n minus 2 times n minus 3, and so on and so on and so on. right? N minus 4, N minus 5, N minus 6, all the way down until 3, 2, 1. Right? I'm just going to put factorial here to stop my expansion. But just remember that this means I keep going in my multiplication. Right? This would be N minus 4, N minus 5, N minus 6, and so on. Okay? All of that is divided by N minus 3 factorial. And the beauty of doing that is that it allows you to cancel out those 2 factorials. Okay, and all of that is still equal to 60. And now we've got something a lot more manageable. Okay, we've got n times n minus 1 times n minus 2 equals 60. What kind of function do I have here?
You have a cubic.
I will have a cubic function here, right? So let's expand everything out. So this would be n times n squared minus 3n plus 2 equal to 60. That's just foiling these 2 terms here.
Can you go up a bit?
Really suggest writing this down if you haven't done so already. And then distributing that n in, we get n cubed minus 3n squared plus 2n equals 60. Bring everything to one side.
How do you, oh.
Now I've got a cubic function. What to do?
Not again. Synthetic division.
We could do synthetic division, but we need to know what factors to synthetically divide by first.
You just start doing random numbers.
Instead of doing random numbers, what numbers could I try?
Factors of 60?
Factors of 60, right? So I can use plus or minus 1, plus or minus 2, plus or minus 3. There's lots here.
Oh, so photosynthesis.
Plus photosynthesis? No.
What?
Right? I've got lots of options. Oh, I need 6 as well. That's a factor. 10 is next. Tell you what, the answer, you'll find the answer before we get to 10. So let's have Riley try plus or minus 1, Brandon try plus or minus 2, Nathan plus or minus 3, Deshaun plus or minus 4, Joe plus or minus 5, Tobias plus or minus 6. Okay? Put that in for n in this
I have 4.
equation and figure out, yeah, you have 4. Figure out which of them equals 0. Okay, I'm going to stop you there because we already have our answer. Well, we have 2 answers. Can you see which one is correct?
Probably the 5.
Why the 5? Because it's not negative. Why does that matter?
Because it wouldn't make sense for n to be negative, and it's a natural number.
N is a natural number because n is the number of objects you're arranging. Right? You can't have negative 3 people. That doesn't make any sense. Right? You get a positive 5 people. That makes sense. Right? So n equals 5 is our answer. Okay? So, and if you need further verification on that, just put 5 in for all of these n's, and everything should work out to be 0 exactly. So, just to recap this method, because you will use this a few times, right? Expand this top factorial until you get a factorial that's equal to your denominator. That way you can cancel it and have something a little easier to solve for in terms of n.
So if that was like n minus 8, then you have to write it all
All the way down to n minus 8. It'd be a really large function.